Now, I know what you might be thinking. Bro, you haven't yet reached 50 subs. Then again, I don't care. I just want to make this video right now so that I can later show it. In other words, I would like to welcome you all to a brand new chemistry related video. Another chemical riddle, that is. Today we will be taking a closer look at a pretty big misunderstanding concerning four lanthanides: lanthanum, cerium, praseodymium, and neodymium. So here's the scenario. A sample of Mischmetal, I think that's how you call it, I'm not 100% sure, has been dissolved in a nitric acid. And, as such, four ions were formed. The question is there a way to estimate exactly how much cerium and how much neodymium there is? In other words, how to identify these two elements that I just marked with a circle. Let's just jump in, shall we? So, as you can see on the periodic table, they are all lanthanides. Lanthanides are about as similar to each other as it can be. As an example, their oxalates, carbonates, and fluorides are all insoluble. Not only that, but their physical properties are ridiculously similar. But then again, nowadays it doesn't mean a thing. Especially when it comes to cerium. You might be all like, but then again it's very similar to other elements. How on earth do we separate that? Well, I'll tell you exactly how it's done. Now that we have all four in form of ions, cations even I might say, we need to boil it. Then add distilled water. And following that, we need one more compound which I'll quickly just add into the mix. Actually, it's a mix of two elements, but whatever. I think you get the idea. Basically, it's sulfuric acid, and a salt as well. That, the salt in question, being ammonium peroxide disulfide. There's some more. Oh, I think you get it. Under these conditions, we get a form of a compound which only cerium ions react with. We get namely cerium tetranitrate along with two ammonium nitrates and one crystalline water. After all of that is said and done, there's a problem. Namely, we need to find neodymium, and there is no easy reaction to identify. Or isn't there? You see, we can use absorbance to identify exactly how much neodymium is in the sample. Neodymium itself has a beautiful color. I think it's green, but I will check, and if I'm wrong, I will put it in the description. Thing is, praseodymium ions are also colored. That red hue is a problem, because praseodymium ions may completely cover the required neodymium. Luckily, though, there is a simple solution to that. Simply oxidize praseodymium to +4, and then it returns it to a transparent state. Now I know what you might be thinking, but what about lanthanum? Lanthanum is already transparent, so we don't need to worry about that. Not in the slightest. And now that we have that, we can easily estimate using absorbance how much neodymium is in the sample. Pretty easy, right? But what if I told you that this here is also a bonus? Let me get a handful of extra elements. Alright, this is that. So again, we have lanthanum, we have cerium, but we also have ytterbium, pardon? I thought that it was iberium. And lutetium. Everything again at a +3 oxidation. And we want to know the amount of cerium and ytterbium. Cerium is easy enough. I've just said about that, so you don't have to worry about searching it elsewhere. But we stumble upon another problem. Namely, all of these ions, well, they are transparent. There is no way to identify how much ytterbium is. Or isn't there? There is one small trick. A tiny one which will help you identify the amount of ytterbium. Now, looking into the periodic table, we can see that lanthanum only exists as a +3 oxidation state. Same with lutetium. Ytterbium, on the other hand, wouldn't you believe it, also exists on a reduced oxidation state of +2. I think you get the point by now. We have to reduce it using a strong reducing agent. Then it will turn into a green color. Again, if I'm wrong, I will just put the correct in the description. And again, measure absorbance. And I suppose that will be it for today's video. If you did enjoy, make sure to leave a like, subscribe, and hit the bell. If we can manage to get 10 likes, that would be greatly appreciated. Also, quick note before we end the video. I will be launching a brand new series with Marcos da Silva, which is my mate from Évora, Portugal, called Amphimaniacs. So be on the lookout for that. And I'll see you guys next time. And until then, have a good one, alright?